Hello guys, we're back for a Friday webcast. I know that yesterday we had some technical problems with the stream. Something was going on with, I guess maybe the YouTube end. So we'll give it another try, and if it doesn't work, we'll figure it out, so don't worry too much. Well, it was another clear night here in our part of Texas. We had some rain earlier, as you saw, and I showed a little bit of footage from when I was going out earlier. I picked up some money from Africa, of all places. Have somebody ordering Forecast Laboratory out there, and did some shopping and came back. And let's see here. Let me get my streams all set up here. Okay, it looks like our audio is going, so I think we're good here. All right, so you can see we're back in the usual pattern. High pressure out to the east, and we're under that southerly gradient. So you see that right there. Winds coming out of the south-southeast into an area of low pressure up in Colorado. So that's often what we see this time of year. So we could probably put a trough extending down into New Mexico. That could be a dry line. The best way to bear that out is to pull up the surface plots, and yeah, we do see a dry line. We've got 61 degrees here north of Midland, dropping very sharply to low 30s dew points around Tucumcari and Clovis. So with that, we could probably put a dry line, maybe something like this. So we go from about 56, 59 here in Medicine Lodge, Kansas. That's way off the top of the screen. Let's try a different station. 60 at Gage, down to 53 at, that's not Plainview, that's Perryton, and then down to 33 at Dalhart. So that's a dry line right there. So if we had enough moisture, we could certainly get some storms out of that. And one more way of looking at the weather is the infrared satellite. And we do have to use infrared this time of year because it's dark. But fortunately, we can look at the cloud tops, and the colder areas, they show up very white. And we can map that white to kind of a bluish palette right here to help that stand out. And then the darker shades are going to be your hot temperatures. And we can see off the bottom of the screen right here, this very, very dark area. That's going to be very warm surface temperatures. So definitely some very warm weather around Yuma, down into the Gulf of California. Now, one way we can look at the weather, and I'm going to pull something up here that's new. And if the audio drops out, if you don't hear me, please say something in chat, and I'll do some changes and fix that. So when I switch this, it's going to cut out to a different audio source. So let's try this. Aha, there we are, plotted weather map. So let me know if you can hear me. And if you can, we're going to get started on this camera. So I'm going to give you a few minutes to respond because there's a little bit of delay in the feed. So anyway, I'm doing this, we're going to try to do a little hand analysis because there's only so much I can do with a mouse. And this is good old hand fashion analysis. I'm kind of limited by the camera here. Okay, somebody says some echo. Let me check my settings real quick. I really didn't have time to run through this. Hang on a second. Okay, how about now? Did that echo cut off? I might have had two mics going here. So I'm going to wait on that, and while I do this, I'm going to sketch out a little bit of where I think the boundaries might be. See a little bit of a boundary right there in this part of Montana. So I can sketch that through. You can see a little bit of southwesterly winds there in Wyoming. Okay, looks like we got our audio problem licked there. Okay, so let's see. I haven't even looked at this map yet. But this is the 7 p.m. central plot. This is 0Z data. So I'm not going to do a thorough analysis. I'm probably going to wait till after the end of the newscast so I don't bore too many people. But I'm going to point out just the main key details that I see here. The main thing that I see here is very mild conditions out in the northeastern U.S. So this looks like an area of high pressure. So you see very light winds there in Albany and up there in northern New Hampshire, and very cool conditions too. So this is probably going to be a little bit of an area of high pressure. And looking at the pressure values right there, that definitely looks like, again, high pressure. So I can outline the 1028 line just very quickly like this, and we can see that's a bad plot. So that's going to go, let me make sure that's covered. I'm going to switch over to my preview. Yeah, okay. So we'll just do that real quick. So our 1028 line is going to go kind of up here. So that's going to outline an area of high pressure over New York. So right there, and that's going to be a 1030 high. And we can also find an area of low pressure up in the Canadian prairies. So we're going to be looking for probably a 996 millibar low, and that's going to run something like this. That's bad data. No, it's actually not bad data. So let me take that out real quick. So basically our 996 is going to look like this, and if you have a surface plot, you can kind of follow along or go back over it later. So the center of this is going to be up here. So you see this very counterclockwise circulation here. That's cyclonic rotation around the low. So you can see that on all three of those plots right there. Okay, and then other pressure centers, I don't really see any others. The one out here in the Pacific looks like it's off the coast. The stuff out here looks like it's an extension of this northeast U.S. high. And in here there might be a bit of a lee side low. So let me finish this up very quickly, and I'll come back to this later. We're probably seeing a bit of a front kind of like this, and maybe a bit of a warm front right there. See, that's 69 right there in northern South Dakota, 75 at Rapid City. So very warm downslope air in this region right here. And then elsewhere, see, not a whole lot. Warm southwesterly winds in Nevada. So yeah, there's probably a bit of a polar front high up in this area right here. So that gives us our basic idea of what's going on. There's a frontal system right here in the Canadian prairies, cool, large, high-pressure area in the northeast U.S., and possibly a Pacific system off the coast. And in here, this is dominated by lee side troughing. So that's the basic setup we have in the U.S. right now, and I'll come back to this at the end. So let me switch microphones here real quick. Okay, so I got the other mic switched on. Hopefully there's no echo. So this matches up pretty well what we have on the surface analysis right here, or on the satellite picture here. So you can definitely see this rotation here in Saskatchewan, indicating our low pressure area. And there's a bit of a baroclinic leaf right here. Baroclinic leaf is kind of an indicator of a shortwave working its way into this system here. In the backside right there, we're getting some lift ahead of that wave. And let's see, this is probably a bit of a cold core low, kind of hanging back behind there, because with baroclinic systems, we see the surface low stacked towards the cold air with height, and that becomes a cold low aloft. So we should see something like that on the upper air charts. And then our lee side troughing out in the Rockies, this looks pretty characteristic. You see that we have a lot of high cloud. This is cirriform clouds. And you see this very distinct gravity wave appearance. See that right there? Intervals of maybe 10 or 15 miles. That's conditions where you have air oscillating off the Rocky Mountains, going up and down and up and down. And with that oscillation, you get areas of condensation and subsidence. And we see that as this herringbone type appearance here. and not much in the way of low clouds associated with those cold core systems. And it does look like there is some other system coming through the southeast U.S., maybe an elevated system right here. So we can check for that on the charts. And that's about all that's going on right there. So you see what I'm doing here? I'm kind of putting the charts together and looking for consistency and kind of putting together everything three-dimensionally. NHC looks pretty quiet. Nicole is still wandering around out there, and it's getting up into the extratropical latitudes. So it's still a hurricane. We're looking at Category 1 there. 971 millibars, that's pretty deep, but the winds are a bit on the weak side there. So let's pull up our thickness analysis right here, and I'll go to the NOAA modeling site and pick up the GFS. So I'm selecting the GFS for North America. And I'm thinking here, maybe we can go and look at the Canadian analysis. Canada CMC analysis. So we can pull that up very quickly. And they should have a forecast panel, actually. So that's going to be under modeling. They have their regional model, which is kind of like our WRF or NAM. And then they have this GDPS, which is kind of like the GFS. So I think we'll go ahead and go with the GDPS, which is kind of like the GFS, actually. Getting Firefox opening a bunch of windows here. Let me get back to where we were. Okay, one of these is going to be our thickness chart, so I'm going to pull that up. I think that's going to be on these 4 panels. So let's see here. These might be a tiny bit messy, but maybe we can give them a try anyway. Okay, that's a little bit better. Okay, so let me read these graphics. Our thickness is going to be right here. So you see it says 1,000 to 500. Change in height, difference in height. So we're going to look at this chart right here. I don't know if you can see that. That might be a little bit tough for us to really work with. But maybe we can pull it off. Maybe I can load this up into PaintShop Pro. So let's see here. Let me do that really quickly. Let's see. Okay, then what I'll do is I'll just resize that very quickly. Image, resize. I'll bring that up to size of our video window. It doesn't, look the greatest, but it's, it's very good to get practice with different charts and not be stuck to the very same ones. Sometimes we have to work with these bad graphics, and it gives us a little bit of practice. So what we're looking at here is the sea level pressure, which is the solid lines, and you see that high pressure earlier this morning over the Great Lakes. And we see a frontal low over Alberta and another one further west out in the Pacific. Now the coastlines, I don't know if you can make that out, but here's Alaska. Hudson Bay is going to be looking like this. There's Quebec. And there's the east coast of the U.S. right there. So that's what we're looking at. And then Greenland is going to be way up here. And then the thickness lines are going to be these dashed lines that you see here. And you can see that the greatest packing is up in Canada, like that. And there's even more up in Alaska, like that. And some more off the west coast of the U.S. right there. So that's where we're going to be looking at for frontal systems. So basically what I'm seeing here is there's a low over Alberta this morning, so that's going to be a little bit further west than our surface analysis. And there's our warm front. Cold front is going to be running a little bit like that. So it looks like maybe down into Oregon. And then this looks like an occluded low here off the coast. So that's detached from the thickness gradient, which is off to the south. And we can think of that front as kind of continuing through the high, even though there's frontalysis in this area. We can kind of find some continuity in here. And then we pick up the frontal system again over Quebec and New Hampshire and New York. And we can find maybe a little bit of a frontal system, or I'm sorry, a warm front right there. And then this segment up here is going to be an occluded front. Okay. And then our frontal highs or baroclinic highs, those are going to be right here. There's one right there in between these two frontal lows, and here's another one. And then as we go west, we can pick up another frontal system off the coast. This one is very easy to see because we're out over the ocean. So the gradients are a lot smoother and you don't have all the state outlines getting in the way. So you see there's a bunch of lines right here. There's our warm front, and then there's our cold front right there. So we can see that this is not all wrapped up. So this is kind of a system that's starting to mature, and it still has a lot of life left in it. It's not quite all the way to being occluded. So it's kind of an open wave system here. Now another good way you can find these fronts is to use boxes. And by boxes, you look at the thickness lines and the pressure lines, and you find where they form boxes. So there's one right there. So there's a box. Here's another box. There's another one. Out to the left, we don't see any boxes out in this area. So there's no temperature advection going on. But yeah, there's boxes right here, boxes up here, and so on. And so basically you just put the front equatorward of all those boxes. And the boxes themselves represent the strongest thermal advection. So you're going to find that poleward of the surface fronts. So that's another thing you can use to help you out a little bit. Now, your eyes are probably glazing over looking at this chart, so we can return to some of our familiar charts here and pull up that GFS. I'll do that very quickly. And I'm going to pull up the 7-hour forecast, so this is valid right now. And now we'll just take a closer look. So now you can really see that thickness gradient up to the north over Canada, another one off the west coast. And just to go over this very quickly, we're just looking at maybe something like this right here. And then this system out over British Columbia, this is going to be that's going to be an occluded system out there. So then the continuation of the front over the northeast U.S., that would run probably something like this. Then it would hook up with the next system further down the line. Now another thing you can really see is the core of the Arctic air that's developing up north. You just basically find the bullseye of thickness. That's way up here. And I'll shift the map up there so you can take a look at that. There's a bullseye right there and another one right here. So right over this area is actually where the Franklin expedition went missing back in, I think, 1847. And they didn't find the ship until about a year ago. It was missing, and they finally found it. It was on this island right there. So obviously a very cold place. They perished there of starvation. And they suspect some of it might have been the spoilage in the rations and lead, that kind of thing, and those old cans. So very hostile up there, and I guess they had a lot of problems trying to survive there. But since then, this has become part of the DEW line, the distant early warning line. So we have a lot of weather stations right along this line that still persist even to this day. We can take a look at a sounding from one of these stations very quickly. So we'll go to the University of Wyoming sounding and just take a quick look at one of them. I'm using this site because they cover a lot of these weird areas up to the north and south. And just for comparison, I'm going to show you a sounding down south from Fort Worth and let you see that. Fort Worth sounding is going to look like this right here. So just kind of memorize that. You can kind of see it starts at, this is the temperature line right here. You can see it starts at 20 Celsius, which is about 70 Fahrenheit. And then it kind of drops off gradually, a little bit of a cap right here, some warm air aloft, and then there's the stratosphere. That's up at about 39,000 feet, 200 millibars. So what's it like up north? I'm going to click on Resolute Bay up here, kind of close to that cold core. So it looks quite a bit different right there. Everything is way over to the left. Now the surface temperatures are not very cold. It's only about -11, which is going to be about 12 Fahrenheit. That's a little bit on the warm side for this time of year. But the big thing is that the cold air above that is very deep. This is a very deep cold air mass. And so it's reflected very well on the thickness charts. So this is basically the core of the cold air in the Western Hemisphere, right there near the station. So you go aloft to the very top of the column, 20,000 feet up, you're looking at a temperature of about -45 Celsius. And when you get down to those levels, that's where the commercial airplanes have to worry about their fuel freezing. So they've got time restriction limits and that kind of thing when they're flying over the poles like this. But above that, you can really see the stratosphere. Very deep. It reaches way, way down. And that's based right there. That's going to be the 350 millibar level, which is about 27,000 feet, so pretty low. So that's another reason why when you're flying over the poles, going to Singapore or New Delhi, you're flying up in this level, up in the stratosphere, and there's been concern about exposure to ozone and that kind of thing up at those flight levels. So it does become kind of a different animal when you're flying in the poles and you're deeply embedded in that stratosphere. Normally down south, when we're in Fort Worth, if you're up at about 37,000 feet, you're going to be about right here, and you can see we're not really in the stratosphere at all. So it's much different down here. So that's kind of a quick look at soundings and how it relates to the thickness charts. Okay, and we'll take a very quick look at maybe the Polar Orbiter satellite. This is the Terra satellite right here. So what are we looking at here? This looks very, very white. There's a very strong albedo from these clouds here over Arkansas and Iowa. So we can zoom down and take a look at those and see if we can figure out what those are. These look to be supercooled water clouds, probably stratocumulus. These are probably stratocumulus layers, and you can see gravity waves embedded in that, maybe transverse bands. And the edges of that look very grainy, so this is probably going to all be low cloud. That contrasts quite a bit from the cirrus that we have further up north, and when you zoom in, you can really see the agricultural fields there. It's like a quilt or something. Might see it better if I switch over to one of the other satellites. There's Aqua, and there's the Suomi satellite. So that looks pretty cool. So by this time, a lot of the Strata-Q is kind of burned off at the edges, and you can see it looks a little bit smaller. And then down here in Texas, pretty much the same thing. This is all associated with warm air advection and isentropic lift, and that's one thing I covered yesterday, and I guess a lot of you might have missed that due to the technical issues. I'll go over that probably in the next couple of days, and we'll revisit all that. And just a quick look up north at that frontal system. Let's check that out really quickly. You can see a little bit of a dry slot working in the backside, so they're getting a little bit of downslope right in this area. And that's going to be southern Alberta. So they probably got a little taste of warm weather, clear skies in there back behind that. So let's go into the forecast here very quickly, since we're running at about 28 minutes. I lost I think I lost the precipitation plot. Where did that go? I'll probably have to regenerate that really quickly, so let me do that. Meteostar GFS, and we'll go to the, not the precipitation, but the precipitable water. And this is where we go over the forecast over the next couple weeks. So we've put together the analysis, and we do have a pretty good picture of what's going on as far as the thermal structure. So there's our baroclinic system right here, our barotropic system, occluded low off the coast. And we'll run it forward, and you can see Nicole right there off the east coast. So going into the weekend, let's go all the way to Sunday. Sunday, we see the frontal system advancing very slowly out into the plains. Conditions look pretty much the same across the country. Big high pressure out over the eastern U.S. There's the lee side low over the high plains. And then going into the work week, much of that frontal system moves into the Canadian, into Ontario and Hudson Bay. Looks like maybe a weak frontal system moving into Texas and Oklahoma by Tuesday. There's the leading edge, maybe a few showers and thunderstorms along that. Then that kind of breaks up and we get into a stagnant pattern. And then we start rebuilding a bit of cool air across the western U.S. right there. And you'll see that expand down. This is about Thursday. This is going to be about 6 days from now. So you'll see it gradually move south and push a front through Texas. This is going to be Thursday night. And it looks like we've got a little bit of a low pressure system taking hold off the Louisiana coast right there. So that's probably going to cause a little bit of wraparound, maybe some cloudy weather across the southern U.S. over the weekend. That high pressure tries to move southward and doesn't make much progress. Well, actually, it does make some progress, but very weakly, and it's going to be a very cloudy type system. And let's see, high pressure builds into the eastern U.S. by the 25th, getting up to Halloween here. And it looks like our next system comes out of the northwestern U.S. right there. There's a leading edge on October 27th, and we get to the end of the run. So we're just getting into a we're getting into a little bit of a progressive pattern here. So we're going to start seeing some interesting weather on the charts here in about a week. So that's about all I have for the forecast, and I'll go ahead and finish up that surface analysis very quickly for those of you who want to hang on and see that. So let me set that up really quickly and go back to the webcam. Okay. Right, see how that works. I know the focus is not very good here, but I'll just finish up this chart very briefly. We did the 996 millibar line. The next thing we would look at is for the 1000 millibar line. But one good thing to do is stagger your lines. So I'm going to want to go to 1004 because that'll give us a much neater presentation. So our 10,004 line is going to go like this. So we're basically following the plots where they say 040. We just kind of interpolate and work our way south. So I'm approaching this front right here, so I'm going to just go ahead and break it up right there and come back to that in a little bit. Looks like a bit of a trough here. Okay. So we're still doing our 1004 line. So I'm going to look for where it connects back up here. Okay. This 120 looks kind of bogus, so I'm going to probably go over that real quickly, just kind of past that. So there's our 1004 line. So you see now we can drop the 1000 line in there, and it should come out looking pretty neat. So there's 1000. And then the other part of the 1000 line is going to connect back up here like this. 1000 right there. Then we'll do our 996. I don't think we've ever done these full analyses. I just got this camera about a month ago, so I haven't been able to do this kind of plotting until now. Okay, so I'm going to skip the 1008 and then I'm going to go to the 1012. So I'm going to come back to the 1008 later. And again, that'll give us kind of a neater picture. So then our 1012 is going to drop, let's see, that's actually going to drop a whole lot further south. Along the Pacific coast. I can see we don't really have a 1012 except around the plateau area of Arizona. You probably remember when we talked about that a month ago. We went over the Four Corners area. Okay, so we pick up the 1012 again in Texas. That's going to go something like that. And then I'll clean this up real quickly. And then 1012 drops, that looks like about plot. 1012 goes all the way down to Mexico like that. So the next line we're looking for is 1016. We'll skip that and go to 1020. 1020 is going to go like this. And then that picks up in the Florida area. Goes right over Mobile right there. Goes like that. And now we can put in the 1024, which is halfway between 1020 and 1028. So there's 1024. And then we find the 1016. We go back to this. And now we've got a pretty good idea where we're going to find that. So that's going to go from the Bahamas out into the Gulf of Mexico, then back up the Texas coast through Fort Worth, then up to Columbia, Missouri, up to central Wisconsin, Oshkosh, and then up to Moosonee, 1016. Now we can pick up the 1008. So you see, once we draw our a few intervals in here, we can just throw the other ones in there pretty easy. So our 1008 line is going to go like this. And then that goes back into the Rockies like this. There's 1008. And what do we have out here? We're looking either for a 1008 or a 1012. Looks like we're going to find a 1008 right in here. And usually when we have these closed contours, we like to mark the top of it. So I'll do that very quickly. There's the 1008, then we find the center. It appears to be right here. And then this is going to be a high pressure area. And I'm going to put that south of that plot because highs rotate clockwise. Okay, so now we can start hardening things in because I think that's pretty much all the contours. What I'm doing now is just kind of looking it over and making sure I didn't miss anything. And I'll just do this very briefly. So I'm going to draw this high pressure offshore very quickly. And let's see here. Actually, here's a couple more contours. I'll just put these in very quickly. 10, 12, 10, 16. Then we have a 10, 20 out here. Okay, so I'm not going to really worry about all this too much. We'll just go ahead and finish up here very quickly. I did miss this 1060 here at Havana. So what I can do is I can just draw that like that and then fix it like that. Some of that attention to detail is very important. Okay. So I think we're pretty much done, so let me harden this in very quickly. You can see our lee side trough going from about Dalhart up to Scottsbluff. And then we can put our cold front up north. Yeah, it looks like our warm front is probably right in this area. You can see that our analysis has shown a little bit of a trough shape here. So that's one clue, without even looking at the temperature field, that we should find a warm front in this area. So you can see we go from 64, 71, and then the temperature drops off very rapidly to 50 here. So that's going to be our warm front right there. And it hooks up with our baroclinic low right here. Then goes back to an older baroclinic low up here. So this is going to be an occluded system in Saskatchewan. And then this is an even older occlusion right there. And that's pretty much probably all the fronts. I think that's all the main features. What I might want to do is check further back here to see if I can find the front any further. I might want to go over trends at each station and maybe look at a zoomed in chart. But for now I can see there's 61 there at Winnemucca. Looks a little bit warm up in Oregon, so I might kind of stop the front right there. And I think that's it really for this analysis. So this matches up pretty good with what we saw on the thickness chart. And if I wanted to spend even more time on this, I could go to the upper level chart, and I bet you I would find a jet up in this area right here on the back side of this cold front, then coming down the north side of this warm front right there. So you should find something like that in the upper level data. But it's probably going to be a broad type of flow because of this lee side trough in Colorado. Okay, so that's our hand analysis for today. So I hope that was somewhat instructive. Wow, 6 people still hanging on there, so I guess that did help a few of you guys. So let me switch over the mic here real quick. Okay. So I think that's about all I got for today, and let me check the chat real quick and see if there's anything I need to be aware of. Let's see, National Weather Service OBMAP, I think I missed that. Not sure what that refers to. Okay. Yeah, a few comments there about the mapping. I guess that's kind of popular right there. The map I hand analyzed, that was digital atmosphere. So I was able to customize the plots and make them look fairly decent for hand analysis. And what you saw right there, those surface plots right there, those are the old legacy National Weather Service fonts. And those date from 1968 from old Fortran code, and I adapted those in a digital atmosphere. So that's a little bit interesting. But they're very visible. I had tried some of the Windows system fonts to do this chart, and I'll show you what it looked like. And tell me if you can read this. Yeah, see, that uses that Verdana font, and it's pretty illegible on the webcam. The other one is much easier to read. It's more of a high contrast font. But it was designed for use with those giant fax machines and did the job quite well. All right, we managed to pull in 43 minutes on this webcast, so hopefully you got your money's worth today. I will be done for now, and you can join me tomorrow, Saturday, at the usual time, 8 o'clock, and I'll see you then. Have a nice evening, everybody.